Yeah, hi everyone. Hey Ganesh, please record the session. Many people are not joined today, so please record it. Okay. So, so the last session we discussed about the different joint part problems. So joint part problems is one of the loop and chasm trap and fan traps. So these are the three problems we will encounter when we join the tables. So with the different dimension tables and the fact tables. So that has been resolved by using the aliases and context. Right? So today we'll see how to improve the performance of the query. How to improve the performance of the reports. So first we'll see generally why the report performance degrades. So whenever you are retrieving the data from the database, okay. Let's see like the data is available in the database. So the data which is available in the database, the time wise. So with the timestamp ID wise, the data is available in the fact table. That means so it's a very high level, very low level information, very lowest granularity level data is available here. So let's take this. There is a time fact. There is a fact table. The data which is available by the time ID wise. So product ID, and storeroom name, store ID, sales revenue, and the quantity sold. Okay. So this is a fact table. So guys, very simple way I'm explaining this. So why we need the why we need the aggregate tables? Okay. So how we improve the performance of the report using the aggregate tables? So which is the fact table one, and I'm joining these tables with the dimension table. So this is the timetable. Timetable. In the timetable, we have the data which is available by time underscore ID and the date. Sorry, date with the timestamp, date with time and the date. Okay, and the week and the month and quarter. Let's take the quarter and the year. Okay. So the data which is going to join with the timetable to the time ID. Fine. And similarly, we have another table. Yes, Nitesh. Yes, I am giving the user access. So there is a product table. In the product table, we have the data. In product table, we have the product ID and the product name and the category. Product ID and the category and the product name. Okay. So product name. And I have another table called the with the store name details. It contains with all the store name details. So in the store name details, so we have the store ID, store name, and the city and the state. So this is the data is available. So to get the product name, product wise sales revenue, we need to join with the product table to the product ID. To get the store name wise or city name wise, so we need to get the data from the joining with the fact table to the store name table. Okay. So see, let's take the data which is available in the fact table, each time ID wise. So if any sales happen the product and based on the store name, so that information it will store in this fact table. all the transaction information is stored in the fact table. Suppose in a day there are 1,000 transactions happening. In a day there are 1,000 transactions are happening. Okay, that means in a 24 hours. So night 12 to the again night 12. So there are 1,000 transactions happening with a different time stamp. Okay, so in the timetable, so with the time ID. So let's take example. See in the fact table. Let's show. I'm just showing the data. There is a time ID 1233 and the product ID is 100 and the store name is 55 and the sales revenue this much. Okay, and similarly there is another timestamp. So with the same product ID and with the same store name, there is another transaction that. Okay, so that means, so assume like this timestamp. So this time ID is nothing but assume like there is a 9 o'clock. So how we can identify that? So on what day and which time it has happened. So if you join with the timetable time ID to the timetable, so I get to know on what day and which time the transaction is happening. Okay. So and see, based on the timestamp, I can get the with the date and time. So in a day, so similarly, so in a day there are every day there are 1,000 transactions happening. Okay, 1,000 transactions are happening in a day. Fine. So suppose if I want to see if I want to see in a month, in a particular month, so so how many transactions happen? So generally every day it is happening 1,000. So 1,000 into 30. That means, so in a month how many transactions happen? So there are 30,000 transactions are happening, right? 30,000 transactions are happening in a day in a different showrooms and different showrooms and different for different products. So there are 30,000 transactions happening, right? Fine. Is that correct? So that means, so in a year, how many transactions will be? It is 365,000, right? So in a day, 1,000 transactions has happened. So in a year, total 365. 365 double zeros. Is that correct? 3,65,000 rows. 3,65,000 of rows data will store in the fact table for any each year. Okay. Again, if it comes to the, suppose there is a 10 years of data is available. That means again, so there are many 36 lakhs of data. So to sum up, see, basically to want to see the 10 years of data, so what I need to do, so if I get the data, if I try to calculate the data from the mean fact table and the dimension table, so there are 365,000 into 10 rows of data will be there. So into 10 rows of data, so we need to calculate. If I get the data from the fact table and time table with the time dimension table data, if you join it, so it will take at least more than 15 minutes to get the data from this fact table and the time dimension table. If you want to see the last 12 years of data, so last 12 years of data for 2000, if I want to see the sales revenue, so to generate this type of report, 2001, so we can create easily. So this type of report we can create easily. But when you run this report, it will take a lot of time. So it will take a lot of time, more than 15 minutes easily. It will not finish less than 15 minutes. Okay, and depends on the database. So using the indexes and the ranches, depends on that. It is going to take more than 15 minutes time to retrieve the data from the base tables, right? So who will wait to just to see the year-wise sales revenue data more than 15 minutes? No end user can't wait more than 15 minutes when he refresh the data, right? So that's why, so we are introducing the aggregate tables. So we are introducing the aggregate tables. What contain exactly in the aggregate table? So whatever the data is available in the different table, so we pre-calculated that all the data and we store into the aggregate tables. So pre-calculated data means year-wise data. So all year-wise data we can store into, we can calculate and store into the separate tables. Okay, year-wise and state-wise and the product-wise. Product means sales revenue and the quantity sold. Okay, so quantity sold. So what we will do? So whatever the data is available in the base table, so we will calculate it separately and we will load into the separate table. So when you see in the base table we have for 10 years of data we have 365,000 into 10 rows of data will be there. But if it comes to the aggregate table, so each year there is a one row, and again each year so there are different states information is there. Suppose let's take example. So each year there are 10 states of data is there, and then 10 products of data. So 10 into 10, 100 rows of data is there. So each year there is 100 rows of data is there. That means, so there are 10 means it's a total 10,000, 1,000 of rows data. So to retrieve the 1,000 of rows data from the fact table, from this aggregate table, so it will come less than second. The data will come into the database less than second. Right? So that way, so we'll improve the performance of the report by using the aggregate table. So who is going to create this aggregate tables? So who is going to create this aggregate tables? Either the ETL team. ETL team is to do this process. So what they will do? So they will extract the data from the base table, from the fact table and the dimension table. They will extract the data from the fact table and the dimension table, and they load into the separate summarized table or aggregate tables. Both are same summary tables. So they will extract the data from the base tables. So once the data is loaded into the fact table and the dimension table, again, so they create a new jobs to extract the data from the base tables and load into the target tables, that is summary tables with the calculated information. So if the data is available here, that means so this job will run every year. So once the 1 year is completed, then so they will calculate that particular last year data and they load into this target table. So that way, so the ETL people will do. Suppose in a project there is no ETL team. So in a project there is no ETL team. In that case, the DBA is going to create this aggregate table. So what type of aggregate table? So he doesn't know how to create the aggregate table. The materialized views they will create it. So basically view and materialized view difference, what is difference? So view is the logical structure of the different tables, but the materialized view, it is a physical structure, it is going to store into the physical data in the materialized view. Okay, so the materialized view, if it is the data is going to store into this materialized view is a yearly base, then when they are creating this materialized views, so they will refresh, they will update the data the yearly basis. Okay, so the DBA people, like we need to give the query to the developer, need to give the query to the DBA guys. So what type of query we are expecting from the base table. So if you give it, so they will create a materialized view based on this table. So basically what type of the query they will create, if it comes to, so this is how they will create, select the year, select year comma, some of this. Suppose like just I want to create a table, I want to create the pre-calculated table just year wise sales revenue. Then so they will do the Sales revenue from, so from what? From timetable, comma, the fact table. So where, so they will join, and so they will join where they will join these tables and update. So they will, I'm not writing the year syntax, but update every year they will make it like this, like that way. So they will create a materialized views. Okay. So what basically it will do? So it will see this materialized view. It will basically store the data is going to store into the physically into this materialized views. So we need to use that materialized view in the table in the init structure. Okay. So we need to use the materialized view in that particular MV. We need to use the inverse structure to get the sales revenue and quantity. So okay, so this is a way we can improve the performance of the report in our web intelligence. Okay, so guys, clear? Any questions? So how we are not doing anything. We are not doing anything from the BO side. So the back end only we are. So we need to ask the ETL team or the DBA team to improve the performance of the report to create the aggregate tables. So they are going to create these aggregate tables. So and how to utilize these aggregate tables? So that we need to do it in the inverse structure. See, it's a simple anyway. Like utilizing the aggregate tables also it is a simple. But if there are, just I given a small example here. If there are many calculations are there, so if we create if we create the from the base table, so it is taking a lot of time. That means are they going to create the many aggregate tables? No. So it depends. So if really required, then only they will do this aggregate tables as a one-time. Because so if we create this aggregate table as a table, so it requires separate space in the database. So it is, and also maintenance activities more. If the materialized view created, the DB has to take care of all this materialized views always. So if it is like a weekly materialized view, if it is weekly aggregate table, then so some admin guy has to manage every weekly all these materialized views scheduled are properly or not, the data is updated or not. So maintenance activities more if we create these activities. Okay. So it is very costly creating the materialized views. So I require the separate space for creating this materialized views. Okay. If required, then only if really the report performance, the data use is used in the base table, it is taking a lot of time, then only so we can go for this aggregated. That is not possible at the BO side. So tuning the reporting, that is not, yeah, we have tuning techniques from the BO side also, but if the data is more, we can't do anything with the BO side. So if you are running the SQL query in the database, so it is taking a lot of time. So and if you run the same report, same type of report, so if it is taking a lot of time, I can't do anything. But if you run the report is running in 15 minutes, and if you run the same SQL query in the database, it is coming in 5 seconds. That means it is a problem with the BO application. Okay. Fine. Yes, it will support. So without any DBA, so DBA should be there. DBA should be there in the project because so we are executing these reports on the database, right? So we are just running we are getting the data from the database. So the DBA should be there. So in our team. Without DB, like who is going to maintain the DB, the database servers of everything? No, it is not possible without DB in a team. It should be there. Okay. Smart users. No, I don't. That I will check and let you know. Smart measures, I never heard some smart measures. What exactly? Okay. So, guess you understand the concept is like what is the purpose of the tables. And coming to the part, RB, suppose here is a year table and year column is there and sales revenue quantity sold is there. Here also we have the year and sales revenue and quantity sold. Is that means are we going to create the multiple dimension tables, multiple dimension object, multiple measure object in the inverse level? No. So no. So we are not going to create the multiple dimension table, multiple dimension object, multiple measure objects. No. So we are if we want to create the sales revenue, so we are going to create the sales revenue with the mapping with the fact table as well as the aggregate tables with a single object only. We are not going to create the multiple objects for the multiple dimension fact tables and the aggregate tables. No. So how we can implement that inverse? So let's see. So I'm connecting the. I hope everybody understand. So how the improving the performance of the report. This is a simple concept. Okay. So now how we can utilize the aggregate tables. That is important in inverse design side. Okay, so say just I'm giving organization. So I hope you understand that aggregate table concept, right? So let's do it. So now I'm using the existing connection, which is the ePassion database. So I'm taking the article lookup table, outlet lookup table, and shop fact table, and I have a fact table, aggregate table is here. So I'm taking the aggregate table here. So here. Let's insert in the calendar here. So what is the lowest granularity of the data we have in the fact table? So the data which is available, we have the weekly basis, not the daily basis of the time stamp wise. Okay, the data which is stored in the fact table is the week wise. Okay, the lowest granularity is the week, and the highest granularity is the year wise data will be there. That means, so each week wise data is available. So in each year there are 52 weeks of data is there, right? So 52 weeks of data, amount sold, sales revenue is there. So to get the week wise data, so we need to join this with shop fact table to the year lookup table with the week wise. And if we want to see the month wise data, so what it will do? So that particular if it is like some fifth month, so fourth month data, that means it is a 50, 49, 50, 51, 52. So these are the weeks. Last month means the last weeks of summarized data it will store. Right? If I want to see the month 12, that means the last week of, so 52, 51, 50, 50, sorry, 49, 48. 4 weeks of data it will aggregate and it will display the data. Right? That way generally happen. And if you want to see the data yearly wise, so that means, so 52, there are 3 years of data. That means 3 into 52. weeks of data we need to calculate if I get the data from the main table, base table. But so what happened here, we have the aggregate table. So the data which is stored year wise, quarter wise, state wise, sales revenue wise data is available. Right? So if I want to see the data year wise sales revenue, then the data should come from the aggregate table, right? So if user want to see the data year wise, week wise sales revenue, then the data should come from the shop fact table. Shop fact table, find article, calendar year lookup table. So if I want to see the sales revenue for the city wise and city wise, state wise amount sold, then the data should come from the base table. If I want to see the state and sales revenue, then the data should fetch from the aggregate table. Fine. So then I am going to create the classes objects. Sorry. So now see, there is a year object is available in this table and year object is available in this table. So that means, are we going to create the separate object for this table and for this table? No. So what I am doing here, so create an object here. So select statement. So there is a function called @aggregate array function. So with the @aggregate function, so we can define object from the pre-calculated aggregate tables as well as the base tables. So aggregate awareness. So we need to follow the order. So which column we need to take first? So first column we need to take the highest level aggregate table. So the data which is highest level aggregate table data is available in this table. So year wise, the quarter wise sales revenue is there, right? But if you go to the fact table, so the data which is available in this table is the week wise data is available. So that means, so which column we need to take first? We need to take the first column as the aggregate, the year column. Then second column we need to take from the calendar year lookup table. The second order. So data will come from the calendar year lookup table. Pause this. Click on OK. Click on OK. Now I am going to create one more object. Year is over. Then quarter. So quarter. So I am taking the aggregate awareness, aggregate aware of. So quarter is available here, and the shop fact table. So sorry, calendar year lookup table is also having the quarter object. So I am taking the quarter object here. Pass this. Okay. And similarly, I am creating the month object here. Month. So month is available in only the single table. So the month-wise data is not available. So month-wise data is not available in the aggregate table, right? So pass this. So it is a number. Changes to a number. Pass this. Click on OK. Right? Month has been created. And similarly, going to create the state object here. Aggregate aware of, and so we need to take the highest level aggregate table first, state, and then the second lowest aggregate table is the outlet lookup table. Then select the state object here. Pause this. Click on OK. OK. Then and also similarly you can take the city. City is not available in this table, right? Fine. And now the measures. So I'm going to create the measures. Sales revenue. Sales revenue. Okay. So the sales revenue is a sum of. So generally, so we need to use the sum aggregate function, right? First, before that, we need to use the aggregate aware of sum of. So I am not writing my own syntax here. You can see the syntax here. Aggregate aware of sum of the aggregate table, sum of the aggregate table n, right? So aggregate table 1 and sales revenue, and again sum of the aggregate awareness sum of the sales revenue from the base table amount sold, right? Pass this economic and number and pass it economic. Okay. Okay. The sales revenue is a measure object, so make it as a measure. Click on OK. Perfect. And the amount sold. So I'm just taking the amount sold, not amount sold, it's a quantity sold. The quantity sold which is not available in the fact table, in the aggregate table, right? Fine. Perfect. So I did not join with the aggregate tables. If you want, you can join, but so there is no common column in any of the tables here, right? So if you have a common column, you can join it, but I don't have any common column in the fact table, in the aggregate tables. Okay, that's done. So anything else we want to create, we can create. So yes, you can create a week also, year week. And also you can create the store name also. So for month, yes, for month I am not created. So per month I am not created any aggregate table, any aggregate array function, right? So month is a just month object. Okay. Okay, fine. So guys, so I hope you understand everybody. So then, like see, so you need to analyze where the problem occurs. So now I can create the report. Still not completed. So it is incompleted in yours, but still, just I want to show you. So where exactly the problem occurs. Okay, just it's taking some time. Let's do it. So now I'm taking the year object and the sales revenue. Let's see how the SQL generated. Perfect, right? If you run this report, so we'll see the data properly. Okay, run this query. So now I am getting the proper data, right? So it's perfectly displaying the data. Okay, but so if I take the month object, so the month-wise data is not available. So month-wise data is not available. Then so the data should come from the fact table, shop fact table, right? So because the sales revenue is not aggregated the month-wise data, right? So now whenever I drag the month object, then SQL query should generate from the base table, not from the aggregate table. But still, the sum of the sales revenue is coming from the aggregate table, and the month is coming from the calendar year lookup table. So there is a aggregate table from class. There is aggregate table and a calendar year lookup table, and year also is coming from the aggregate table, right? So by default, it is taking the first column, right? So basically, year also year object. So if you take the year object is also the multiple columns. So what happened here? So by default, it is taking the first column. Is that correct? So by default, it is taking the first column. Right? But this is a wrong query which is created here. This is a wrong information, wrong query which is developed. Even if you run this query, so if there is no joint between the tables, so we will get a wrong information. It will not give the proper records, right? So actually this data is displaying the more records. This is not proper data which is displaying, right? Correct? So what need to do? So to display the data. Again, if I take the city, see basically if I take the state object, so the data which is displaying, so each year and state wise data will be there in the aggregate table. So I can generate the proper data. It will give the proper records, right? It will give the proper records. So the state wise data is available, and it will display in our report. But if any user, if any webby developer, if we create a report a year and state with the city wise, then the problem occurs because the city wise sales revenue is not available in the aggregate table, right? The city wise sales revenue is not available in the aggregate table. So if there is no join between the two tables, so the Cartesian product will form and it will give the wrong results, right? So what exactly my requirement is here? If user taking the detail object, if user taking the month object, if user taking the quarter, not quarter, city object into the query panel, the SQL should generate from the base table, not from the aggregate table. Okay, guys, I hope you understand what is the problem is occurring here. If user taking the city object in the query panel, so we are getting the wrong results. That means the inverse is not properly set up. So we need to do some changes at the inverse level. I hope it's clear, everybody. Any questions here? Okay. So once you insert the aggregate table, once you create the object with the aggregate tables and the main table, base table, then you need to set up the aggregate navigation. You need to select the aggregate navigation panel here. Okay. So in the aggregate navigation panel, we need to set up the incomputable object. So with this, see, shop fact table. With the shop fact table, is anything is incomputable? No. So with the shop fact table, we can create a report year wise, quarter wise, month wise, right? Yes. And outlet lookup table is not incomputable. But aggregate table, so this aggregate table is incompatible with the city object because the city wise sales revenue is not available, and aggregate table is incompatible with what month object, and the aggregate table is incompatible with the shop, and also year week, and also the quantity sold, right? So aggregate table is incompatible with these many objects, and calendar year lookup, no. Outlet lookup table, there is no incompatible object. For shop fact table, there is no incompatible object. So only these are the object only is incompatible with the aggregate table. Okay, click on OK and save this universe. Export this universe to the repository. Now create a new report. Yes, sir. Yeah, I will send it in. Okay. Now, see guys, if I take the year and the sales revenue, so if I take the year and sales revenue, let's connect to the design tool. So the data which is like SQL is generating from the aggregate table. Okay. So the SQL is generated from the aggregate table, right? The year and see, let's take the year object. So I create, so year wise the data is available. So the data which is displaying the sales revenue. So if you see the SQL, okay, properly it is displaying and run this query. Okay, it's perfect. Even if I take the month object, then so how the SQL generating? The SQL, the sales revenue should come from this table. How it is coming? See, if you see the data, the amount sold is coming from the amount sold is coming from the fact table. So how it is displaying? Because of, see, it is going to check. So is year object is compatible or not? If it is incompatible, then it will generate a query with the first column. Suppose so year is incompatible, but month object is not a compatible. Month object is incompatible, right? Okay. So month object is incompatible. Then immediately it will skip this column to generate SQL query. Then it will try to like once it is skipped, then is another column. It will try to create a query. So even if this is also so incompatible, then so it will try to create a query with other column. Okay? So that way it will work. But anyway, the second column is not incompatible with the month object. Then so it will create the SQL query by using the base table, right? So then you can see the proper records, month-wise data. You can see the correct data, right? And similarly, so if I am taking the state, so if year-wise state data I am taking, then the data which is coming from the aggregate table, and if you run the query, so we'll see the proper data. But whenever if I want to see the city-wise data, then SQL should generate using the base table, because city-wise data is not available in the aggregate table, right? So city-wise data is not available in the aggregate table. Similarly, same way, so the SQL will generate from the base table, because the city is incompatible with the aggregate object columns, right? So this is a way. So we can utilize the aggregate tables in the infrastructure to improve the performance of our reports. Okay, yes, any questions? So this is very important. So you can see all the real-time scenarios, all the projects. You can see the mini aggregate table. So there is a separate monthly aggregate tables, weekly aggregate tables, and there are separate aggregate tables you will find in the real-time scenarios, real-time projects. Okay. So fine. Any questions, guys? Okay. Okay. Thank you. So we can continue the session tomorrow at the same time. It's India time will be with the 5:30 morning. Okay, thank you. And Sayed, so yeah, I will send it to you soon. Yes. So once it is completed, maybe after 2 days, maybe not tomorrow, day after tomorrow, we are going to start with IDT2. Okay.
And are you going to teach any different databases, SAP? How to extract data from SAP BOBJ?
Yeah, that we can discuss with IDT2, not in 3.1 within UDT.
But in 3.1, how to access DEX queries and all, you don't discuss that?
Yeah, that I will show you how to access the and how to access the the web queries from using the UDT tool. That I will show you in 4.0 servers.
But 4.0 has a direct access, right? 3.1 doesn't have it. So how do we know that?
Yeah, that I will show you.
Okay.
Okay, thanks, miss.
The organizer